All right, here are our solutions for quiz one. Part A here, we're asked to find the slope of the secant line to this function up here, and given two x values. X1 is 2 and x2 is 3. Let's see, I guess what you need to know here is that the slope of the secant line is y2, the change in y, divided by the change in x. So we're given two x values here, x1 and x2, which will go in the bottom here. We need to figure out y1 and y2. Maybe I'll do that in a different color off to the side here. Y1 is just the same as f of x1. It's kind of saying what comes out of this function when you put x1 into that function. X1 is 2, so it's really just f of 2, which we can figure out. Negative 2 times 2 squared plus 4 times 2 plus 1. If I put in a 2 everywhere, I have an x up here. This is what I get. Be a little bit careful. It's the x that's getting squared here, not negative 2x or something. A lot of people will get rid of the negative sign somehow, but you don't want to. We get negative 2 times 4 is negative 8, plus 4 times 2 is 8, plus 1, negative 8 plus 8 plus 1 is 1. Do that same thing. Y2 is f of x2, which is f of 3. Okay, now we replace all the x's in our equation with 3's. So let's see, 3 squared is 9 times negative 2, negative 18. 3 times 2 is 12, plus 1. Let's see, that's negative 6 plus 1 is negative 5. So if you figure out all that work off to the side, we have everything we need over here. Y2 we said was negative 5. Y1 was 1. X2 we got up here is 3. And X1 we got up here is 2. So negative 5 minus 1, negative 6, 3 minus 2 is 1. So the slope of the secant line between those 2 points is negative 6. All right, moving on. Part B, explain how you could estimate the slope of the tangent line using secant lines for this function at this point. Okay, so everyone's answer will be a little bit different here, but basically the idea is the tangent line is the limit of the secant lines as the 2 points get close together. So we could find the slope of the tangent line maybe we could estimate the slope of the, let's change that, we could estimate the slope of the tangent line by looking at the slope of the secant lines, or at the slope of the secant line as 1 point stays at 2 and the other point gets close to 2. Something like that. I don't know if that's a great explanation. Hopefully that's close enough for you to get what I'm getting at there. But you know, obviously everyone's going to state that a little bit different. But basically the idea is all a tangent line is a secant line when the 2 points that create the secant line get arbitrarily close together. So that's kind of what I'm trying to describe here. Okay, suppose this function is modeling the height of a ball at a time. Interpret your answer to part A. All right, part A was the slope of a secant line. You may remember that the slope of a secant line is average speed. So because slope of secant line represents average speed -6 from up here represents the average, kind of the change in the height, the average speed that the height is changing at, the average speed that the height of the ball is changing, is traveling. Between the two times that we were given up here, between time t equals 2 and t equals 3. Between times 2, I guess we're talking about seconds, and 3. Something like that. Still supposing that f of x is a function modeling the height of the ball at x, interpret the meaning of the slope of the tangent line to f at x equals 2. Okay, maybe I should not be so wordy in these. Basically, the idea is the slope of the tangent line represents the instantaneous speed. So that would mean that the instantaneous speed of the ball, of the height of the ball, interpret the meaning of, is represented, is given maybe. Ooh. Is given by the slope of the tangent line. Something like that. This first quiz is doesn't feel very precise, but that's just kind of the way it goes with this early stuff. Later on, we'll have more exact answers. Actually, in this problem, we'll have more exact answers. Here's g of x. Here's this function. We want to evaluate the following things if they exist. What is g of 2? G of 2 is just asking what is the height of this function when x equals 2. Looks like x equals 2 right here. The height of this function is this colored in circle, which happens at 1, 2, 3, 4, 5, 6. Looks like it happens at 6, as it kind of tells you right here. So g of 2 equals 6. What's the limit as x approaches 2 from the negative side of g of x? The negative side is over here in the picture. So what we're saying is if we're on this curve and we get really, really close to 2, what does the height get really close to? It gets really close to this height right here, which is 4. Down here in part 3, we're asked what is the limit as g of x, as x approaches 2 from the positive side of g of x. Here's the positive side. As we get really, really close to 2, we're on this line right here. We get close to this height, 5, 6, 7, it looks like 8. So this is equal to 8. And finally, the limit as x approaches 2 of g of x. What you do to figure that out is you look at your answers to part B and part C. If you wrote the same number there, that's the number you wrote down here. Because these two numbers are different, we'd say this does not exist. Maybe I'll even write parenthetically because 8 does not equal 4. Something like that. I guess that's the end of this quiz.